Okay, all right. So today we are going to work on day two of three for solving systems with substitution. Okay, so that's what we're gonna do. So we're gonna substitute for 2 more days just to get as much practice as possible, and then we'll move on. Okay, so let's take a look and see what happens. All right, so here we are. We are going to look at, so let's see where we were yesterday, right? So yesterday I gave you these sort of, I'm going to point out to you by using an highlighter. All right. Yesterday, we worked with a very, very specific set of systems of equations for substitution. Okay. What do I mean by that? Here, right off the bat, I went with a super duper simple substitution question, right? Where I'm literally telling you what x stands for, right? And it's a numeric value, right? And also, as you can see, right here, I gave you y, right, equals, I gave you x equals here, I gave you y equals, and then y equals, so on and so forth, which means this, all the all these questions have at least one equation where the variable has been isolated. So let me just use a very strong, right? Isolated, let me use rainbow. I don't want to use rainbow. Rainbow's the best. We have to save those for special occasions. That's not very good either. All right, right? Isolated. This was isolated. This was isolated. Isolated y, right? The x here is isolated. The y is isolated. The x is isolated. So everything is isolated, which means you know, I kind of made it a little bit easy for you to substitute. Okay. So today we're going to look at a different type of systems of equations, which is this. Now, I believe you can, as you can see and understand, that right here, we didn't have anything that's isolated because that means, what I mean is this, right? X is next to either, the variables are either right next to a coefficient or it's being added to a different expression or different term, right? So y here is not isolated like it was because here is right next to negative 5x, right? And so on and so forth. So that's the challenge for today is how do we solve these questions exactly, right? Now, uh, so here's a little tip for you guys, right? Whenever you're solving systems of equations and you decide to choose, and this is a choice, by the way, because most of the time on the regions, they don't specify which method to use. They don't care if you graph, they don't care if you substitute, they don't care if you use elimination, which is the next topic. All right. Sometimes they just want you to get the job done. All right. And so they're not gonna do that. They're not gonna tell you what to do. Unless, there's special occasions where they specify they solve this by substitution, by graphing, so on and so forth. Right. So how do we approach this? Well, if you see a system of two equations like this with the first equation and the second equation, look at both equations and right off the bat, see if you can spot a variable that's by itself, meaning it has a coefficient of 1. So 1x or 1y. Try to spot that first because that tells you that you can do the following. All right. So now here, can you spot the variable that doesn't have a coefficient? Yeah, this one, right? The y, the plus y here. So what I'm gonna do is I'm gonna pick on that one to work on. So what am I gonna do when I work on this? I'm gonna set y to be by itself. So in other words, think of it like this. You know how this is, when we were graphing, when we were talking about standard forms and whatnot, right? Slope intercept form. This thing is in standard form, right? So standard form was ax plus by equals c, right? And as you remember, slope intercept form was y equals to mx plus b. So if I were to turn this into this, I just have to solve it like a literal equation. And that's what I mean. So meaning I want to solve for y. So how do I get y to be alone? Oh, I'll add 5x on both sides. That cancels out. I got y. And here I got 5x minus 2. right? So a month ago, if I were to ask you to turn this equation from standard form to slope-intercept form, that's what you've done, and that's what we're doing now. So we're not doing anything crazy. So here we got our new equation, right, from this. And now you see that y equals, I'm going to substitute it into this here. All right, so that's all this is. This is just an act of literal equations and substitution. So let's do that. So I got negative 3x plus 6 times, right, instead of y, I put 5x minus 2 in there, right? I substitute, right? So 5x minus 2 equals to negative 12. So in other words, we're solving for x because we're going to know what y is in a second, right? So, okay, let's solve that. So I distribute, right? Remember, that was like one of the first topics that we did, right? Distribute, combine, solve. 6 times 5x is 30x. 6 times negative 2 is negative 12 equals to negative 12. OMG, what do we do now? All right, what topic is this? Yeah, combining like terms. Right? So far, so good. So we're going to add 12 on both sides. Now, you can see probably like one of these questions take a very long time to solve. All right, it's a journey. It's not a question. Okay. All right. So we got these cancels out. X is 0 over 27, which means x is 0. That's kind of good. Okay, because that just makes everything easier to solve. Now, that means my x value is gonna be 0. All right, in the solution. Right. The question is, what about the y value? Right, and here we can just substitute. I'm going to pick the easy one. I'm going to pick this equation. So we have negative 5 times, right? So here, where x used to be, now put a 0 in there. So 5 times 0 plus 4 equals negative 2. That's negative 5 zeros is 0. Y equals negative 2. And so here, I'll put 2 here. And there's our solution. All right. Our solution is 0, negative, 0, 2. Now, if you really want to check for the answer, you can. You just substitute 0 for x. Let me see if I have a stronger marker. I'll use red, okay? 0 for x and 2 for y. 0 for x and 2 for y. So negative 5 times 0 is 0 plus 2. Right, hold on. Wait. Oh, is it negative 2? It is negative 2. Oops. Wow, okay. All right. Wow, you see, I'm really glad I checked my answer, actually. I made a mistake down there. Right, negative 2. Right, so that's negative 2. And then negative 3 times 0 is 0. 6 times negative 2 is negative 12. So they both checked out. So I know that this answer is correct. Okay? All right, I know that's a lot of work. So why don't we do one more, and then let's go back to class and just practice. Right? I got to erase all this. So if you were writing this, just rewind and go back. Now, let me pick another question. I really like this one, but I think it's better off we do this in class. So let's see. You know, I'm going to do this just for the sake of space. All right, so this one. So here, right, I got x plus 3y equals 1, and then the other expression. So again, right, first step, scan, right? Which variable can you isolate, right? Now, that would be x. By the way, if you want to isolate y, you could. It's just more work. So let me show you, okay? Let me show you why is more work. So if you want to isolate the 3y, that means you have to subtract x on both sides. By the way, don't do what I'm doing right now. I'm just telling you what not to do. Negative x plus 1. Look, if you want to isolate the y, solve for y, you would have to do, not only do you have to move the variables around, you still have to divide. Like, that's a lot of work. You know what I'm saying? So one of the things you will learn by the end of this unit is when to use what. When do you graph? When do you substitute? When do you eliminate? Okay? So try to work smarter, all right? Not harder, all right? Okay. So here I'm going to go again. So x plus 3y equals 1. So I'm going to focus on the x, right? So I'm going to subtract 3y from both sides. Now, it's perfectly okay because maybe some of you are doing this right now and thinking, yeah, but Mr. Ring, that's not slope-intercept form. Slope-intercept form starts with y, right? That's okay. I'm not asking you for the slope-intercept form. I'm just asking you to isolate a variable, right? So whatever gets the job done, right? That's what you would have to do. All right. Now let's see. I isolated this, and here I got the expression that I'm going to substitute this into. So here I got the x. So this expression, I'm going to substitute it right in there. All right. So that means I got -3, and in parentheses, this whole expression. -3y plus 1 minus 3y equals to -15. Okay, so here I'm going to distribute. So -3 times that's 9y minus 3 minus 3y equals to -15. All right, combining like terms. All right, you see how everything you've learned in the past 2 years, it's very helpful to you right now, right? What just happened? I think you just pressed erase by mistake. 3, 6y equals to -12. So y is equal to -2. So my solution would include -2 here. I need to know what x is, so I'm going to pick the easy one and substitute. Y is -2, right? So x plus 3 times -2 equals 1. All right. Am I right? I'm just still double checking. Yeah. X minus 6 equals 1. So x is equal to 7. So this is 7. All right. And so your solution is 7, comma 2. All right. And then you can check your answer by substituting these values for x and y into both equations. Okay. Wow. Okay. That feels very long. Yeah, it's 12 minutes. So let me sign off right now and we'll come back to class and practice. Okay. All right. See you in class.
OMG, that was so good.